Okay, so on to our next adventure in trigonometry. We are going to be graphing sine today. Next lesson, cosine. Third lesson will be tangent. But today we're just going to focus on sine. And so when you're graphing sine, these are the parent points that we're going to use. So when the x is 0, which is right here, the sine graph starts at 0. And then when the graph goes to pi over 2, which is in the unit circle, pi over 2 is right here. When it gets to pi over 2, this is going to go up to a height of 1. So we're going to label that 1. So what I want you to write under there is maximum, because the pattern for sine goes 0, maximum, 0, which is here, and that happens at pi. Then it goes minimum, so -1, so at 3 pi over 2, so here was pi, 3 pi over 2, it has a minimum right here of -1, and then it goes back to 0. So that's an easy little pattern to memorize, 0 max, 0 min, 0. So there's our 5 points, and it makes this curved pattern. Do not make V's, please, it makes a curved pattern. But one of the properties of sine is that its domain is from -infinity to infinity. So this right here is called one rotation. So this right here is one rotation, and after it goes through one rotation, it just starts repeating that same pattern over and over again. It's a wave. So it'll also repeat it back this way too. So what we would have is 0 right here. Then you would have maximum, 0, minimum, 0. So the sine graph goes on forever and ever and ever, okay, in both directions. The range of the sine graph is from the height here to the height there, so from -1 to 1. And in this parent graph, it says A, which is the number in front. Right here, the number in front of the sine of x is 1, so the range is going to be from -1 to 1, which it is. Okay, so again, these are the 5 points right here that you need to memorize for this graph. Next, we have to talk about the period. The period is 2 pi divided by b. And you're like, where the heck does b come from? B is right there. It's the number b for x, right? So if you look up here in the sine graph, the number before x is 2 pi, and 2 pi divided by 1 is just 2 pi. So another word for rotation is period. So how long does it take to go through one period? Okay. If the a in front is negative, just like before, it's going to reflect it over the x-axis, and we'll see a couple of those in just a minute. So again, what we're focusing on right now is first the 5 points of sine, which is 0, maximum, 0, minimum, 0. You can also say this, 0, a, 0, -a, 0, which is a is the amplitude, that's what a stands for, and that's the height of the function. So you might have seen something like this already in science class. Okay, so let's take a look at this first problem right here. It says, graph the following trigonometric functions, identify and label the period. So we can't just graph it, we also have to label it. So what I want you guys to do is do this. A, B, and then the period. Okay? A is the number that we first come across. So A is 3. B is the number b for x, which is 1. So it looks like there isn't a number b for x, but mathematicians are lazy, so we're going to write it like that. And then the period is 2 pi divided by the absolute value of b, which is 2 pi. Okay? So what we're going to do is, in order to get this period to line up, we're going to count out 1, 2, 3, 4 spots and put that's where our one full rotation is going to end, is at 2 pi. Well, if this is 2 pi, then this must be pi. And if this is 1 pi, then this is half of pi. So 1 half, 2 half, 3 halves, and so on. Okay? Now we're going to label the other direction. That's negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. I didn't do that up here. We always label our graphs. Let's go back and do that. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay? So this is what our graph, the x-axis looks like. Our a value is our amplitude, that's our height. So we're going to be going all the way up to 3 and negative 3. So I'm going to label that. And then we're going to follow our pattern for sine. Sine goes 0, maximum, 0, minimum, back to 0. So there is the graph. Okay? And now we're going to finish it over here. So where would the next point be? It's going to be, since we're going backwards, we're kind of reversing the pattern. So it looks like that. Now, you might think, wow, that graph and that graph look almost identical. You are right. They are almost identical. This is y equals 3 sine x, and we know that when there's a number in front, you multiply the y values, and it will vertically stretch your graph. So you don't have to do this. I'm just showing you guys, here's the sine graph. You see how the 3 stretch the graph up, and it continues just so that we're consistent. Okay, so the orange graph is just y equals sine of x, or 1 sine of x, if that helps you. Okay, now we're going to move on to the next one, and it's y equals negative sine of x. So we have to label a, b, and the period, because it's asked us to do that. A is the number in front, which is negative 1, so already I'm going to put reflect over x-axis just to remind myself. The number before the x is also 1, you see, 1, and then the period is going to be 2 pi divided by b, which is still 2 pi. So 1, 2, 3, 4, this is 2 pi, okay? For the most part, we're always going to make our last increment 2 pi, but we might have to stretch or shrink our graph accordingly. All right, so the graph would go like this. Actually, let me just label these real quick. So if this is 2 pi, this is 1 pi. If this is 1, this is 1/2, or pi over 2. 1/2, 2 halves, 3 halves, 4 halves. Okay, and then I'm going to go back the other way. Okay, so this is what the sine graph typically looks like. It goes 0, maximum, 0, minimum, 0, and it repeats that here as well. But what we're doing is we're reflecting our graph over the x-axis. So this point that was a maximum becomes a minimum, and all the minimums become maximums. And if it's on the x-axis, because that's our line of reflection, it just stays right there. So there's that graph. It's just the upside down graph of the other one. Great. Moving on. Uh-oh, things just got a little bit different. Look at this. Now we have a number b for x. What do we do with numbers b for x? All right, so first thing we're going to do is what we always do, a, b, and period. We'll be doing this for cosine as well. A is the number in front, so that's a 1, and then b is the number b for x, and the period is 2 pi divided by the number b for x, and it's actually the absolute value of that number, which is just going to give us 2 pi over 2, which equals pi. So way out here is 2 pi, but our graph goes through 1 rotation in pi. So what we need to do is cut our graphs into fourths so that we can do 0, maximum, 0, minimum, 0. Because right now, we're not going to go all the way to 2 pi because this says, hey, I'm a speed demon, and instead of taking to 2 pi to go through my pattern, I can do it in 1 pi. So this is 1, this is -1, it goes 0, maximum, 0, minimum, 0. So there is our graph, like that, okay? And then we're going to label these just because. So if this is 1 pi, this is half. And if that's what's half of a half, that's a fourth. So I'd kind of do it without the pi. Like, you know, like I just ignore it. I'm like 1, that's 0.5, that's 0.25, or that's 1, that's 1/2, that's 1/4. And then once I get the first increment, I just work the other way. This is 1/4. And then the next one would be 2 out of 4, which simplifies to that. And then this one would be 3 out of 4. And that's 4 out of 4. And then we're going to go back the other way, but we got to cut those in half too. So we get -pi/4, -pi/2, -3pi/4, and -pi. And then we're just going to make sure we follow the same pattern. So this graph will also come over here and finish, so you can just keep following that pattern. It asks us to only graph 1 rotation, but we have just graphed 4 rotations. How do I know I've graphed 4 rotations? How many times have I done this pattern that's right here, where I go 0 max, look, 0 max, 0 min, 0. 0 max, 0 min, 0. Back to the beginning, 0 max, 0 min, 0. So I've actually graphed 4 rotations of that. Now what does the sine graph look like? So this graph right here is y equals sine of 2x, and this is just a good skill to label your graphs. What would the sine graph look like? It would actually look like this right here. It's 1 rotation. It takes 2 pi to go through 1 rotation, but our graph only takes 1 pi, so it's faster. So notice it's the number b4x, and that would mean you'd take all your x values and multiply them by 1/2. We don't actually have to do all that crazy math because the amplitude and the period take care of it for us, but it's the same thing that you have been learning. Alrighty, we're ready for the challenge of Part D. Part D asks us to do 2 things. It switches our A value from the parent graph, and it switches our B value as well. So the amplitude is 3, or the A value is 3. The B value is the number before the x, so that's 4. And then the period is 2 pi divided by the absolute value of 4, which is going to reduce to pi/2, or 1/2 of pi. So we know this is 2 pi, this is pi, this is pi/2. Guess what, guys? This is going to be crazy. Our graph up here did 1 rotation in pi. This graph right here squeezes that whole pattern in from 0 to pi/2. Isn't that crazy? So I'm cutting those into 4 equal pieces. We always cut into 4 equal pieces, so we can do the pattern of 0, max, 0, min, 0. Okay, so I'm going to go back the other way. So 0, I'm going to go the same, max, 0, min, 0. And like, guys, this pattern keeps repeating in each one of these pi/2s. I'm not going to be very good at drawing it because, you know, we're in this, but that's kind of cool. So that's it right there. That's crazy. So that graph is so smushed, but it was no problem for us. We know what to do. Okay, -2 sine of x. So I have my AB and my period. So my A is -2. I'm going to reflect over x-axis. Don't just write reflect because there's so many different types of reflections in math. This is a reflection over the x. The number before x is 1, which I like because that leaves my period alone. So I'm going to go all the way out to 2 pi. So I'm going to label all these guys real quick. this is the pretty standard label right here. Whoopsie. That's okay, we'll just do that. So that's why it's ingrained in my head. And then the parent graph would go 0, max, 0, min, 0. And the max and min are all at that amplitude, right, of 2, which I should label on my graph. But what we're going to do instead is we have to reflect all those points. So these guys can't be reflected because they're on the x-axis, but these guys can. Oops, that's not the right point. Come on now. Alright, so I'm going to go like that. Okay, so there is that graph right there. That is our reflected sine graph. Now, you can always check your graphs in your calculator. So if you go into y equals, looks like my children have been messing with my calculator. No worries. We're going to type in -2 sine of x, which is the button right there. Same button, and hit graph. Look at that. Okay. So this increment right here is from negative 10 to 10, which is not what we're in. So if I wanted to go from 0 to 2 pi, you can actually go into your window, and then this should be -2 pi. And then this will be 2 pi. It's just something fun. And then each increment is scaled by pi over 2. So if you're like, why is it changing it to a decimal? That's just 2 pi and -2 pi, and this is pi over 2. And then I can hit graph. So you can see what shape the graph takes. Alrighty, that's it for today's lesson.